This is Map2check, a bug hunting tool that verifies safety properties in C programs and, as of the current architecture, in WebAssembly binaries. It combines symbolic execution and fuzzing over LLVM16 and the KLE backend, tracking memory and pointer safety. It's open source, and the full artifact is reproducible from this single repository. Let's build it from scratch. Step 1. Clone the repository and enter the project root. Dependencies are resolved by CMake. No manual submodule wrangling. Everything the reviewer needs is in tree. To guarantee a reproducible toolchain, the environment is fully containerized. LLVM16, KLEE, WABT, and the WASI SDK, all pinned in the development image. First, we build the Docker image. No host contamination. Then we enter the container, mounting the source as a volume. We configure with CMake and Ninja, then compile and install. The self-contained distribution, binary, KLE, instrumentation bitcode, and the WASM runtime lands in the release directory. Notice that the Map2check binary will be mounted on release folder. Let's verify a real property. This C program contains a known memory safety violation, an invalid free. We invoke Map2check in memory track mode, which checks for invalid frees, invalid dereferences, and memory leaks. Map2check reports the free violation and returns verification failed, a precise detection, not a false positive. Each verdict ships with a machine-checkable witness, so the result is independently verifiable, exactly what artifact evaluation requires. If we add the -- generate -witness option, the Map2check will create the witness as a .xml. Now we take a C program with a heap buffer overflow, an out-of-bounds write past a 10-element array. Now here's the differential of the current architecture. Instead of a dedicated WASM engine, Map2check lifts the binary to LLVMIR and reuses its existing instrumentation and KLEE backend. We compile it to a WebAssembly binary with the WASI SDK. From here on, Map2check never sees the C source, only the .wasm. After this compilation example, we enable the WASM pipeline on Map2check. The binary is lifted and instrumented for linear memory bounds checking, and KLE explores the lifted IR. In this case, as it is a really simple code example, the verification process just takes a few seconds, but in more complex examples, it can take up to 300 seconds. Here, Map2check detects the out-of-bounds write inside the WASM module and reports overflow. The same property model, the same witness format, now on third-party binaries. Now we use the --generate-witness option to generate the .xml witness of the .wasm compiled file. Everything you saw is public, containerized, and scriptable, reproducible from a single clone.